Hi everyone and welcome back to my channel Cloudtechs.club. I'm excited to kick off a brand new series focused on Git and GitHub, a quick and practical journey through one of the most essential tools in the DevOps toolkit. Now, just to clarify, this doesn't mean I'm wrapping up the existing Kubernetes and Ansible series. Those are very much active and new videos for them are already in the pipeline. I'll be updating those series soon. This new series on Git and GitHub is designed to take you from the basics all the way to advanced concepts with a hands-on approach that fits right into the larger DevOps learning path. So let's jump right in with today's topic, an introduction to Git, a powerful and widely used source code management tool. So in this lecture, we will cover the fundamentals of source code management, SCM. We will explore how it works using the Centralized Version Control System, CVCS, and Distributed Version Control System. We will also dive into some interesting facts about Git, one of the most popular tools in this space. But first, let's understand why we need Git in the first place. Before jumping into how it works, it's important to know the problem Git solves, like code versioning, collaboration, and tracking changes effectively in any development workflow. In IT companies, software development is typically a collaborative effort involving multiple developers. Each developer works on different parts of the application, contributing code in smaller segments. Managing and integrating these code contributions effectively is what we refer to as a source code management. For example, let's take a large scale platform like Facebook. Some engineers might be working on the login page, while others are focused on different areas like the newsfeed, messaging, or notifications. Each team handles a specific part of the application. In the past, before modern tools like Git existed, all these code contributions were often merged manually, which was not only time consuming but also highly error prone. There were no reliable way to track changes, manage versions, or collaborate efficiently. To overcome these challenges, various tools were developed to handle source code management and maintain proper software versioning. These tools help track changes, collaborate efficiently, manage different versions of the code base, and ensure smooth integration across teams. There are two main approaches to source code management. One is Centralized Version Control System. Another one is the Distributed Version Control System. So let's proceed with understanding what is Centralized Version Control System and how it works. A Centralized Version Control System, CVCS, relies on a single repository to store all the code and version history. In this system, every developer checks out the latest version of the code from the central repository, make changes, and then commits those changes back to the repository. Let's take an example to understand how the centralized version control system works. Suppose this is our central repository server. We have workstation PC1, PC2, PC3. Suppose PC1 works in the IST time zone, or we can say this developer is sitting in the IST time zone, while this developer is working in the US time zone. Now, the IST time zone developer logs in and made few changes into the code and pushed the changes to the central repository. The same code will be checked out via US time engineer once he will log in. Then he will make few changes into the code again, let's say with some green lines, and pushed the code to the central repository, and the same code will be used by IST time zone engineer once he will logs back in. In this way, the project is synchronized across time zones with engineers working on the same code base but at different times, commenting and pushing their changes to the central repository. This allows the team to collaborate across regions while ensuring everyone works with the latest version of the code. Let's see the advantages and disadvantages of the CVCS. First is the simplicity. Another one is the centralized control. It is easier to set up and use, especially for smaller teams or projects. While it provides the centralized control, a single repository for all changes means a centralized management of the project. Likewise, we discussed here in this example. And disadvantages. First, it's going to be the single point of failure. Next, limited offline capabilities. So, if the server or a repository went down by any chance, PC1 won't be able to update the codes to the central repository, and PC2 will not receive the updates. So it's having the single point of failure. No one can access or update the code. Next is the limited offline capabilities. So developers must be connected to the central server to commit or update the codes. Otherwise, it's a single point of failure. Let's proceed with understanding the distributed version control system, where each contributor has a local copy or clone of the central repository. This means every user maintains their own complete local repository, which includes all the files and metadata from the main repository. Let's understand this with the help of a diagram. Let's say this is your central repository. You have PC1 or workstation 1, PC2 or workstation 2, PC3 or workstation 3. This is we are discussing DVCS. One of the examples of DVCS is Git. Okay. Here we have local repository. This is going to be the again local repository. This is also going to be the local repository. This is our workspace. where we write the code. So from workspace, we commit the code to the local repository, and from local repository to the central repository, we push the code. And we pull the code from the central repository and update from the local repository to workspace. Same here. This is going to be the pull request. And this is going to be the update. Pull request and update. Let me write it here as well. This is going to be the push request and commit, push and commit. So this is going to be your local machine. So you have local repository sitting on your local machine and your workspace. While this particular repository, the central repository, it can be your GitHub, while Git works at this level. Okay. So let me read the DVCS. Each contributor, each PC, each workstation is having the local copy here, local copy or clone from the central repository. This means every user maintains their own complete local repository, which includes all the files, metadata from the main repository. So this is how the DVCS function. As I told, central repository can be GitHub, and while the Git tool works on the local PC. So in short, Git is the tool, while GitHub is the platform that helps, shares and manages Git repositories. Right? Let's go ahead and see few advantages of using the DVCS. There are a lot of advantages, but I will discuss few of them which are very important. First one is local repository access. Each developer has the full copy of the repository, including the history, allowing them to work offline without needing a constant connection to the central server. So they can work within the offline state of central repository. Another one is the faster operations. So most of the operations are performed locally, making them significantly faster compared to the centralized system. Enhanced data safety. Since every contributor has a full copy of the repository, locally, right? It's more resilient to data loss. Even if the central server fails, any clone can be used to restore it. Full history tracking. Every clone has the complete history, enabling better traceability and auditability of changes. Another one is the reduced dependency on central server. Unlike CVCS, which is our central versioning control system, distributed versioning control system does not rely heavily on the central server. It reduces the single point of failure. So as we saw earlier, single point of failure was the disadvantage of the CVCS, which got resolved with the help of a DVCS. Okay, let's discuss the different stages of the Git and its few of the terminologies. There are 3 stages of Git. One is workplace, another one is the staging area, the third one is the local repository. So workspace is the place where you work on your files, modify it, and write the codes. Another one is the staging area where you prepare the changes before committing. And the local repository where Git stores the history of your commits. Let's understand this with the help of a very simple example. Your workspace is like your room where you have all your clothes. This represents the files you are actively working on in your project. The staging area is like a suitcase where you pack the clothes you plan to take on a trip. These are the files you have selected to commit. The local repository is like your travel destination. Once the files are committed, they are safely stored there and you can access or revisit them anytime. Let's understand this with the help of a small diagram to make it more clear. Git stages. So there are 3 stages. What we have: workspace, which we also call as working directory, where we write the code and modify it. Staging area and local repository. So let's say you have one server. Okay, it's just for an explanation purpose. There are 3 partitions. Okay, this is your workspace This is your staging area, and this is your local repository. Let me have different color. So this is your workspace. This is your staging area, and this is your local repository. And here you have a central repository, which is GitHub. Okay, so the workspace, this is where you create, edit and delete files, essentially your active deployment area. All visible files on your local system reside here on the workspace. Next is your staging area. Before committing changes, you first add them to the staging area. Think of this as preparation zone, where you group specific changes that you plan to commit. Next is your local repository. Once changes are finalized in the staging area, they are committed to the local repository. This stage saves the snapshot of your project along with metadata, forming part of the project versioning history. From workspace, the file can be sent to the staging area with the help of add command, and from staging area to the local repository using the commit, and from local repository to the central repository using the push, and from central repository it can be pulled to the local repository using the pull. So these are the three stages of Git. There are various terminologies which Git uses. We will discuss all of them one by one. So the first is your repository. Okay, a repository is a storage location for your project source code, where you keep the code, project code, right? These are of two types: local repository, and the another one is the central repository. This is like GitHub, or you can say it's a Git tool which works on the local repository. Next is the server. So server is the platform where you host all the things, right? Remote repositories and manage associated metadata such as commit IDs, tags. It enables collaboration by allowing multiple users to access and contribute to the same code. Another one is the working directory, which we have already discussed, a workspace, right? Another terminology is the commit. A commit records changes made to the files in the repository. Each commit generates a unique 40-character alphanumeric identifier known as commit ID. So whenever you make changes to any file within the repository, it generates a 40-character alphanumeric identifier, which is a commit ID, to identify that this particular change was done by this particular user. That's how it keeps the track of the changes of the versioning within the system. So we have commit and the commit ID. Another one is the snapshot. A snapshot captures the state of the project at the specific point in time. Git uses the incremental model. It uses the incremental snapshots, meaning it stores only the differences since the last snapshot rather than the full copy of the project each time. And the another one is the push. The push operation transfers the committed changes from the local repository to the remote repository, while the pull operation, the pull operation retrieves the changes from the remote repository like a GitHub to the local repository. So these were some terminologies which we use with the help of a Git, which we discussed, like repository, server, working directory, commit ID, snapshots, push, pull. Let's see few advantages of Git. First one is it's free and open source. Git is freely available and open source, making it accessible to individuals and organizations without licensing cost. Another one is the fast and lightweight. Git performs most operations locally, such as commenting, branching, and viewing history. This local execution results in high speed and minimal latency. Next one is the security. Git ensures data integrity by using a cryptographic hashing algorithm, SHA-1, to uniquely identify every object, such as commits and files in the repository. This prevents tampering and ensures consistent tracking of changes. No need for high-end hardware, since Git operations are efficient and primarily local. It does not require powerful hardware as always on internet connectivity. Next is efficiency. Branching. Creating a new branch in Git is quick and efficient. Git uses lightweight pointers, so branches are created without duplicating the entire code base, enabling seamless experimentation and parallel development. So branching is altogether a big topic within Git. We are going to cover this in our upcoming lectures. For now, let's wrap up. Thank you for watching this video. If you found the content helpful, don't forget to like, subscribe, leave a comment, and share it with your friends. Thank you.